Well, so I took that cone to work, checked up in the lathe, spun it, did a test spin, make sure everything was going to be fine, wasn't going to wobble and explode and all that. Being old cast iron manifold. Worked great. Well, you know, it did till it didn't. Remember that crack I showed you in there? Well, first off, here we go. Nice finish all the way around until you get to the chip. Here's my chip. So I brought it home to see how much of this has to be on the exhaust manifold, and it turns out you have a hole right here. I need this piece. I even started to turn that down a little bit, a little shiny on there. I need that there. So I need to figure out how to get that to weld, which I haven't had good luck with welding cast iron, and most of the time people don't have luck at all welding old exhaust manifold. It just doesn't work out. So I'm going to take this back to work, do a little research, and see if I can get this piece welded on, or if I can build this up. I don't think we have brazing rod at work, so we may end up just using stainless hardwire. We'll see. We'll be right back. Does this place look familiar? Nope. So we're at my dad's shop. So the cone piece, as I showed you, broke right there. Here's my piece. I've decided to weld it. I mean, I've tried cast iron welding with no luck. I watched a couple videos on YouTube, and I'm gonna try it again. I think the one difference I saw on YouTube that I didn't do is I did heat up my cast. I already had it ground out, heated it up, and then I welded. Well, I laid a bead on it. The two videos I watched, they're just squirt welding that in there. So we're gonna try that. I mean, it's just a little piece, and it doesn't have to hold anything except for it needs to keep the exhaust from blowing out. So it just needs to be there. It's not clamped. It just has to rest there. There's plenty of there's plenty of surface area for it to sit on. It doesn't have to rely on that little piece other than to just block the exhaust. So we're gonna get set up. We're gonna clean it up with the grinder. I'm gonna show you what I'm gonna do. I'm not saying it's right. I'm sure it's wrong. I mean, I've done it with stainless 308 wire at work, because I heard that has the most nickel for MIG welding. But the videos I saw, they just used steel hardwire. So that's what I'm going to use. That's what my dad has set up in his welder. So yeah, we'll get this ground out, we'll get it heated up, and then we'll try welding. Well, as you can see here, we get it all cleaned up, shaved off. That's cleaned up, rust is gone, nice and close. Put this in the right direction. I'm not going to weld on the bottom, I don't need to, so I'm going to try welding here, here, and a little bit across the top. There's only 2 clamps, so I don't necessarily have to worry about this spot here. I can clock it just enough. So hopefully, just like that, we'll have it. So next step, I'm going to fire the torch up and then we will weld it. Well, now that I'm half blind because I don't have the the right eye protection for running that torch, too impatient to try and set up my dad's hood to work with the torch and then have to reset it, so I'm not real don't know how this particular hood works. So I got that on there. This didn't change color, but just grabbing it with these gloves is plenty warm. Before it starts to cool off too much, I ground this. I did kind of bronze up a little bit. We're going to put our ground on there. I cleaned that up right there. Get the hood on. Alright, here we go. And I hope I don't start a fire. There we go. I didn't want that. I'm gonna have to clean that up. Turn the wire speed down. We'll build it up a little bit. Oh, where'd the whoppers go? Still doesn't seem quite right. Looks like I'm just building it up, and I'm burning that little piece of cast away. I don't see it cracking yet. That's all right. We'll get this built up and we'll grind her clean. God, that looks terrible. Uh-oh. Well, here's a close-up. It looks terrible, but exhaust manifolds aren't easy to weld on, especially the cast iron in particular, but exhaust manifolds, as the heat from running the engine tends to burn out the nickel or in the cast. So I'm gonna wrap this up. I'm gonna let it cool overnight, and then I'll grind this to shape. Well, it's the next day. We're at home, and we're going to unwrap the coveralls to see if the welding held up on that exhaust cone. I don't know how many of you weld, but they say that what is it? There are welders and there are grinders. And if you gotta grind your weld to make it look nice, well, then you're not a welder. But I take exception to this. That was exhaust burnt and heated repeatedly, lots of nasties in that cast iron. It's not my fault. Maybe. Anyway, see what we got. No cracks, no cracks, no cracks. I don't see any. No, it looks like a chicken sat there and did its business, but I'll take it. So what I need, I'll take a grinder to it. I need to clean up this bottom edge where it's nice here. I need to match that all the way around back over to here. So I gotta get that weld nice. I'll probably clean this up just a little bit, but I don't want to take too much off. You can see right here, there's a crack right there because I didn't weld the underside. I just need this piece, again, I just need this piece to stay and keep the exhaust from coming out. And if I welded here, I welded across the top right there, like that. I'll leave that weld. I'll clean this up and I'll clean this up. I'm not going to bore you with it. I'm just going to go do it. So we'll be back when I get it cleaned up. Well, you want to see? Can you see it? There it is. So, see the bottom right there. Oh, let's turn that. There we go. Oh, focus. There we go. So there's the crack, original crack, that dark spot right there. So ground this down here. Here, let me set this down. So ground that down there. I did end up smoothing this off. I couldn't stand looking at it, so I knocked it down a little bit with the cutoff wheel. Flap wheeled here, and then I took the cutoff wheel down here, and the welds down here weren't really sticking to much, which was good. It made it easy, so I just followed this line right here and until I got it knocked off, and then did enough just to make it flat. So, and then this, you know what, let's talk about that, because on here you're not going to be able to see it. Let's see, don't drop it. Right here there's an arrow, and right above it it says hot, H-O-T. Right here there's another arrow, and right here it says medium, and then here it's cold with another arrow. On the exhaust manifold itself, let me set that down so it doesn't fall off the stool. There's an arrow right there. There you go, now you can see it. So those arrows are to line up with that arrow, and according to the owner's manual, right here, exhaust manifold heat control. The heat manifold is equipped with an adjustable heat-controlled damper, which gives better engine performance when operated correctly. So this is your damper. It controls how much heat just goes directly out the pipe. So let's read. Oh, you know what? Just put it down there. It's not going to roll off of that. I mean, really, I'm surprised that the weld held on that old exhaust manifold cast iron. So I take the chance and have it fall a few feet, and then I get to spend 85 bucks anyway. All right, where were we? Performance when operated correctly. The three main positions are hot, medium, and cool. Oh, cool, not cold, but cool. Okay, turn the page. We're on page 16. The hot position is to be used when the tractor is operating under a light load and burning tractor fuel during cold weather. The medium position is to be used when the tractor is operating under a heavy load and burning tractor fuel during hot weather. The medium position is also used when the tractor is under a light load and burning gasoline during cold weather. That's a lot to take in. The cold position is used when the tractor is under heavy load and burning gasoline during hot weather. So if you didn't know, back in, I guess up into the 50s, early to maybe mid 50s, a lot of tractor companies were using tractor fuel or distillate as lower grade fuel. Some old tractors, they had two fuel tanks, one for gasoline and one for the distillate, however they pronounce it. So tractor fuel, that was the cheaper version, but gasoline you could make more power but gasoline also costs a little bit more. The same thing, kind of the same reason they went with propane power is propane was cheaper than gas. Although propane wasn't prevalent all over the countries, mostly I think down in the South, Texas, Oklahoma, places like that. So yeah, and any more, well, here, let's go on this last paragraph. The engine knock while under load may be an indication that the manifold is too hot. Smoke from the exhaust indicates incomplete combustion and may be caused by the manifold being too cool. And then the last little bit, the damper may then be adjusted to any point where the engine runs best, according to the load, fuel used, and temperature. So it's almost like what they're saying is, if you change that manifold, that cone, you could get it to run better. You know, if you see smoke coming from your gas engine, you know, if you see black smoke, then you're burning rich. If you're burning lean, then it's gonna, under a load or a heavy load, it's gonna pop. It's gonna act like it's missing. So what it's doing is running out of gas. So on the carburetor, on a Marvel Shebler, that's your high-speed needle valve. You back that out for more fuel, you turn it in for less fuel. And then you have your distributor, which is right there. So you can change timing, you can add or remove fuel from the carburetor. But they decided to go with, yeah, with that manifold cone. God, did they give it a real name? A damper, heat-controlled damper. Yeah. So it almost seems like there's two other ways you could control the power during different seasons. I understand cold weather, you know, you want your engine to warm up quicker maybe, so you adjust that and you can build heat faster and it runs warmer and builds temperature, keeps condensation out of the engine, on and on and on. So anyway, where's that thing at? We're gonna run it on, what did it say, cool? So right there, right where the repair was, C-O-O-L, arrow, it's lined up. So then you take that clamp, take that bolt and clamp. It's supposed to be 2 studs. Oh, wrong way. And you put that in. Anyhow, there's the nut. I'm going to, yeah. I'll get that tightened down. Gas tank is done. I just hadn't put it on because I wanted to mess with this. So, yeah, little history lesson, some work. Engineering at its finest. I mean, I think that started in the 1930s, maybe the mid-30s on the Twin City Minneapolis Molines, the KTAs and that model. If you're a Moline person and you know more about this than I do, please chime in the comments and teach us. So anyway, that's taken care of. Get the gas tank back on. Fired up with the muffler on. So I guess that's going to be it. It's about 7 o'clock according to that clock. 52 degrees. I've had dinner. I'm full. I'm tired. I want to go in the house and relax. So we'll see you in the next video. Thanks for watching. Please subscribe. Hit that like button. Leave a comment down below. And yeah, again, we'll see you next time. Thanks for watching.